G'day everyone, I am Tian and today we're going to talk or take a look at muscle contraction, or more specifically, the sliding filament theory of muscle contraction. But before we can start with the process, we first have to take a look at some anatomy. So first we're going to start off to look at the muscle structure. So if we look at the picture here, we'll see that muscle consists of fascicles, or also known as muscle bundles. Fascicles in turn consist of muscle fibers, and muscle fibers in turn consist of myofibrils. Myofibrils in turn consist of sarcomeres. For today's purpose of looking at the sliding filament theory, we're going to have to work with the sarcomere part. So let's take a deeper look at the sarcomere, or a closer look at the sarcomere. Sarcomeres are made up of a series of protein known as actin filaments and myosin filaments. So if we look at the next picture here, we'll see that the blue lines represents actin filaments, and the red lines represents myosin filaments. The myosin filaments is twice as thick as actin filaments. Therefore, we talk of the actin thin filaments and the myosin thick filaments. The black lines represents the Z discs, or the Z lines. The actin filament is connected directly to the Z lines, whereas the myosin filament is connected to the Z lines via a coil-like protein called the titin filament. So let's take a microscopic look, or closer look, at one actin and one myosin filament, which is shown here by this next picture. So if we look here, we'll see that the black dots on the actin represents the actin binding sites, and the yellow line that covers the actin binding sites represents tropomyosin. Connected to these yellow lines are the yellow circles, which represents troponin. So now that we have looked at the anatomy, we can start with the process. So the process starts with the nerves sending an electrical impulse towards the muscle. This in turn causes the sarcoplasmic reticulum that can be found on the outside of the myofibril to release calcium. These calcium ions, which was released into the sarcoplasm, then binds to the troponin, which causes the tropomyosin to move away from the actin binding sites, causing the actin binding sites to be open and exposed for the myosin head to bind to. While this is happening, adenosine triphosphate, or ATP, binds to the myosin heads and gets broken down into adenosine diphosphate, or ADP, and 1-phosphate ion. The energy that's created by the breakdown of the ATP to ADP and phosphate causes the myosin heads to cock into place and bind to the actin binding sites. This binding between the myosin head and the actin is known as a cross bridge. The myosin then moves or slides the actin filament towards the middle or the center of the sarcomere. This movement is known as the power stroke. The sliding movement is also where the name the sliding filament theory comes from. The movement of these actins towards the center of the sarcomere pulls the Z lines closer to one another. When this happens, more ATP then binds to the myosin heads, which causes the cross bridge to break off, or for the cross bridges to break and the myosin heads to go back to its starting position. This process of the myosin connecting to the actin and moving it will keep on continuing while there is still calcium and ATP found in the sarcoplasm. Once the calcium or ATP is used up, the process will stop. This process that causes the Z lines to move closer to one another causes the sarcomere to shorten. The sarcomere that shortens causes the myofibrils to shorten, which causes the muscle fiber to shorten, which causes the fascicles to shorten, which causes the muscle to shorten. We don't really talk about the muscle shortening because the actual term we use when this happens is concentric muscle contraction. So in conclusion, let's recap. Let's quickly recap. Calcium ions binds to troponin, which causes the tropomyosin to break off of the actin binding sites. ATP then connects to myosin heads and gets broken down into ADP and phosphate ions. The myosin head then connects to the ATP and moves the myosin heads then connects to the actin, which moves the actin towards the center of the sarcomere. This movement of the actin towards the center of the sarcomere pulls the Z lines together, which shortens the sarcomere, and in turn causes the muscle to contract. Thank you for your time. Before you leave, can you please go take part of the short survey? The link to the survey is linked down below the video. Thank you for your time and have a nice day.